necklace of Tutankhamun's is made of different colored gems. But it was the carved yellow-green scarab in the center that caught his eye. The scarab was said to be made of a mineral called chalcedony, a fairly common semi-precious stone. But D. McKelly was not convinced. Surrounded by armed guards and museum officials, D. McKelly was allowed to examine and test the jewel. He was assisted by local geologist Ali Barakat. Tutankhamun's necklace was carefully removed by the museum's curator. Using a refractometer, D. McKelly measured the scarab's optical properties, the refractive index. Every mineral has a specific refractive index. The test revealed that D. McKelly was absolutely right. The scarab was not a semi-precious stone. It was, in fact, made of glass. But it was not a glass like any other produced by the ancient Egyptians. Its color, its purity, everything about it set it apart. The tests convinced D. McKelly that the glass wasn't man-made. So what was this glass, and where did it come from? Since D. McKelly's remarkable discovery, several scientific teams have traveled to the Great Sand Sea to try to find answers, to explain the origin of this unusual glass. Now a new team is trekking to the remote area where the glass was originally found. It's a difficult 3-day drive through the desert before they can even start looking for any glass. Physicist Mark Boslow has never been to this desert, so he relies on geologist Ali Barakat and geochemist Christian Kerbel, who, like Barakat, is an old desert hand. They hope to find fresh evidence of the mysterious event which must have taken place out in the desert.
We scientists have been interested in these desert glasses for a very long time. It's just such a mysterious glass. They have a color and this pure silica composition that makes them really unique in the world. We know no other natural glasses that look like this or have a composition like this. And so we scientists are still kind of puzzled how these things form.
What puzzles scientists is that this desert glass is not like any other natural glass found on Earth. Most natural glass is volcanic in origin. Volcanic glass forms when hot, molten magma solidifies rapidly, usually when it meets cold water. Volcanic glass is relatively common, but its chemical composition and dark color are quite different from the desert glass. There is another way natural glass can be produced, by an event more dramatic than a volcano, a collision with an extraterrestrial body. When a large meteorite hits the Earth, the intense temperature, pressure, and rapid cooling can turn the ground into glass.
There are glasses that form by meteorite impact, and we know these. There are, for example, these glasses here. They're called tektites, and they are thrown away from impact by hundreds and even thousands of kilometers from the crater. But these glasses are very different in appearance and shape and size from the desert glass that we have here.
The glass appears not to be volcanic, nor is it like any other known meteoritic glass. In fact, it's unlike anything found on Earth. There have been many theories to try to explain what it's doing in the desert. One theory suggests that this area was once a swamp, and that the glass was left behind as sediment when the swamp dried up. A key to this theory is that the glass formed slowly at low temperatures. For years, this premise intrigued scientists.
When I first heard about this idea, I thought, well, it's an interesting one, that it forms at low temperature. But I wasn't quite convinced that the desert glass really formed this way.
To test the theory, Kerbel decided to analyze the glass to establish at what temperature it had actually formed. For help with the study, he went to the Natural History Museum in Vienna, where one of the world's largest collections of meteorites is housed. Using the museum's electron microscope, he examined the desert glass for a mineral called zircon. Zircon is remarkably stable, but starts to disintegrate at high temperatures. Kerbel looked for zircon crystals with light and dark patches. These patches show that the zircon had begun to disintegrate.
And what this tells me is that the glass formed at a very short time and a high temperature. And to understand exactly which temperature we're looking at here, I need to analyze the different bits inside here.
In the dark patches, the zircon is broken down into a form of silica. The amount of zircon left in these patches shows how far the process of disintegration has gone.
In the darker areas, we have less zircon and more silica. And what this tells us is that this little zircon crystal has decomposed partly because of the high temperature, but not completely. And the ratio of the two elements tells me that the temperature was about 1,800 degrees Celsius.
And that's hot, extremely hot. Nearly 3,300 degrees Fahrenheit. Volcanic lava is only about 2,000 degrees Fahrenheit. Whatever happened here, the heat it produced was phenomenal. What Kerbel found convinced him and other scientists that they had to look for another explanation, an extraterrestrial explanation. And there's only one thing that they need that could create such a shockingly high temperature that it melted the ground. A meteorite happening with Earth.
Tons and tons of this material falls on the Earth every day. And most of them are very small, just like dust. Some of them are pebbles, and they make shooting stars in the atmosphere. And sometimes a really big meteorite hits the ground at very, very high speed. It melts the ground, it vaporizes the ground, and these high temperatures and pressures are enough to melt a huge quantity of rock.
And even though the desert glass is so different from other meteoritic glass, Kerbel thinks it must have been formed by a meteorite. Kerbel hopes to find evidence of a massive meteorite impact on the ground. The team still has another day of driving before they can even start looking for any glass or any other signs of what occurred. They are now in the heart of the Great Sand Sea. It's one of the most arid, inhospitable places on Earth. No one lives here. It can be 10 to 20 years between rainfalls. Extreme even to the Sahara.
Yeah, the glass area is always a new camp at the end of the rock and the camp here. Like that, we make the camp sort of in the middle of the height of the big glass. And I want to be in the certain area.
There are no roads, no tracks. parallel sand dunes stretch for hundreds of miles. Each dune is a challenge, and without highly skilled drivers, the cars could easily overturn as they slide down the soft sand. Very few people who venture into this part of the desert dare to tackle these dunes, preferring instead the safer route, driving up from the south between the sand ridges. The team has chosen the quickest route, even though it means crossing an endless series of dunes. At last, they approach the area where the glass was originally found. One of the mysteries about the glass is that it's scattered over an area as big as Delaware. The glass is not thick on the ground, but pieces can be found scattered between the dunes.
I'd seen pictures of the glass before, but the first time I reached down and picked up a piece and held it up to the sun, it was very exciting.
No one knows exactly how much glass is in the desert. Estimates range from hundreds to thousands of tons.
Oh, here's a piece. Yeah, look at this. There's a nice one. And another one. So this is an area, and look down here on the ground, you can actually see it. If you look here, you see the nice pieces lying around here. There is a piece here, there's a piece there, there's a piece over there.
Most of the glass lying on the surface is small and round, sandblasted and polished by the sand and the wind. Some pieces are buried and are larger and rougher.
This one here is mostly pitted and dull because it has been sitting underground, and only the nice smooth shiny part was exposed to the sand, and underground it has been etched by water over hundreds or even thousands of years.
The sand dunes are moving at an astounding 10 yards a year, so new pieces of glass are continually being uncovered. And although there are no obvious signs of a meteorite impact,